Hello everyone. Today we're going to go over instantiation. More specifically, we're going to be solving this problem here. We're going to implement a 6-to-1 mux with 5 2-to-1 muxes. So to start off, let's go over how a 2-to-1 mux works. A 2-to-1 mux has 3 inputs, A, B, and cell, or we can rename it, but here that's its name. If cell is 0, the output y will assume the value of a. So let's say we have a is 0 and cell is 0, then y will be 0, it like steers in. And if a is 1 and cell is 0, then y will be 1. And if cell is 1, then y is going to assume the value of b. So if b is 0, then y is 0. B is 1, then y is 1. So that's what that does. Okay. So we have our 2-to-1 mux here. And if we're going to instantiate it, we need to create a top level module. Mux 6-to-1. And according to our schematic, we have 2 inputs, an array of I for the inputs, and an array of cell for the select lines, and 1 output. So input 0 I, input 20 cell, and output out. So with this here, we have declared the inputs and outputs of our top level module. So now we can begin to instantiate. So let's begin with IN0. So for IN0, the first step to instantiate an instance is you copy it, paste it, write down the instance name, so it's going to be IN0. Then you put a dot in parentheses near all of them. So now that we have that, let's make another template for the other ones. So let's get started in this first one. In this first one, in port A, we have I0. So in port A, we're going to write I0. In port B, we have I1. So we're going to write I1. For cell, let's trace that. With the select line, we have cell 0 connected. So it's going to be cell 0. And the reason why this cell is capitalized and this one is not is because this cell corresponds to the cell declared in the top level module, and this cell is the name of the original port, which in here it's lowercase. And then looking at our schematic again, the output, which is connected to port Y, is Y0. So we need, and we don't have Y0 in our top level module, so we need to declare wire 3, 0, Y. Oops. 3, 0, Y. So then we write Y right here. Now let's continue. For IN1, same thing here. Cell. So IN1, IN2 are both connected to cell 0. So let's just fill that one. Then IN1 is connected to I2 and I3. Wait a minute, what's going on? Oh, we made a mistake. In IN0, it's Y0. And in IN1, right here, it's Y1. So then for IN2, it connects to I4, I5, and Y2. Okay, we are almost done. For Y3, Y0 and Y1 are the places where A and B are. So Y0 goes into port A. So in port A, we write Y0. Y1 goes into port B for IN3. So we write Y1. Cell 1 goes into the cell port of IN3. And Y3 is the output of IN3. And then for the last one, Y3 and Y2 come in. Y3, 2, and then it was cell 0. And then this one will be out because it's the output connected to the output of the top level module is connected to the output of IN4. So this should be correct. Well, just to make sure and confirm, we're going to make a test bench for that. So to make a test bench, let's close the hardware manager. We go here, and if you need to make a test bench from scratch, you go there and do simulation sources, create file, and then you would write TB, press OK. But we already have one, so we won't do that. Just delete this. This is something else. Let me delete this old thing real quick. Module TB. So to write a test bench, there's 3 steps. The first step is to copy the top part, is to copy the declaration of the module you want to test. Then you reformat it. Just call it UUT, unit under test. And then we do our, hold on. And then once you do that, take this and you convert all of the inputs into registers and all of the outputs into wires. So this is the first step. You take the inputs and outputs of your original port, change the inputs to registers, outputs to wires. The second step is to then create the instantiation of it. So here we just do this. This technically is good as is because it's in the right order, but let's just use the good practice that we did earlier with instantiation. So this I goes in here. What am I doing? Then this cell goes in here. And then this out is here. So this is the second step of making a test bench. The last step is to make an initial begin block where we control our inputs. So let's set I equal to 6 tick B001101. So that's what I is. Then we're going to set cell equal to tick B000. Then we're going to wait 100 units of time. We're going to change cell some more. Let's run the simulation. So let's see, cell 0 is 0. And when we set the select line to 0, out 0, so it's correctly steered this to there. When cell 0 is 1, this value of 1 gets steered to there, so that's correct. So let's continue. Something happened, hold on. Alright, so it's 1, 2, 3, 4, 5, 6. These are, we're going to steer. Hold on. So right now, since since I is this value right here, we're actually sending in this. And then we're going to apply our stimulus. So when 0, 0 goes in, 0, 0, 0, it's going to set this one to 0, which is going to select A. So then this 0 is going to go there. And then this one, it's also going to select A. So then that 0 will go there. Then this one, it's also 0. So then it's going to go there. So out will be I0 when it's 0, because 0, 0, 0 in binary is 0. We change this to 1. Now, because this is 1, cell is going to steer B. So B is going to go there. But these two are still 0, so it goes out. So now out is equal to I1. And if you keep going through it, you're going to see that when you apply the binary number for 0 to 5, it steers out its respective input to the output. So we're going to run the test bench again to prove that it's working. So here, 0 got steered out, 1 got steered out, 2 got steered out, 3 did not get steered out, and 4 did not get steered out. No, 4 did get steered out. And 5 got steered out. Why did this one? Maybe we messed up. Let's see. So which test case messed up? When cell was 3. So here, when cell is 3, it's going to select this one. So then I3 comes here. It's going to select this one. So then I3 goes here. And then it's going to select 0. So then I3 will still go there. So, But yet out was 0. Hold on, let's go to make sure we have our instantiations correct. Oh, I see the problem. Right here, this needs to be cell 2 because you check right here, IN4 is connected to cell 2 right here. So now let's run it again. And we should see it working correctly this time. So 0 is here, 1 is here, 2 is there, 3 is there, 4 and 5. Okay, good. So the multiplexer is now working. So that's all for a test bench and for creating the source file. But now we're going to create a constraint file